the service request inbox and waited for the screen to load. Okay. What Dynatrace then captured for me was the 3 server-side requests that went to the server. So let's take a look at the first one.
Okay, so Kevin, I'm not sure if I got your invite to some screen share.
Who's that talking?
Mandar.
Oh, sorry, Mandar. No, you didn't. I don't know why. Is there anybody else that I missed?
Sunil, he missed you also, right? You there? Oh, Sunil Patel.
Okay, now I'm getting it.
And I had to invite Mandar.
Okay.
Are you signed on? For some reason it's not. Ah, there you go.
I just got it. Yeah.
Okay. So, Mandar, I'm going to keep going. If you need me to double back on something, just let me know. So, when just to give you an overview of what's happening, these are the 3 requests that have come into the server. Okay. It gives me the agent name, which is both the application as well as the node. So if it goes cross node, we'll be able to see it here. The duration time is the total time from start to end that the execution took. So in this case, this request to the get inbox data took 4.4 seconds. The next section here is the PurePath hotspots graph. So basically this is a visual representation of all the time that we're spending in the application. Right? When I look for this graph, there are 2 things that I usually look into when I see it. If I see something like this where there's one large bar that dominates time, that's usually an indication that we've got one major problem taking up a lot of time. So in this case, we have a perform list method that took 860 milliseconds. Okay? The other thing that I generally look for when I'm looking at the PurePath hotspots graph is this kind of pattern, where I see basically the same, looks like the same pattern over and over and over again. Usually what this indicates is, and it's very common throughout our applications, we do data retrieval, which takes a long time, and then we iterate through all of the records. We spend a little bit of time on each record that we get back, and so that's kind of what I see here. Right. The bottom section is really the most powerful part of the PurePath view of Dynatrace. So let's take a look at this. We're still at the same request. Okay. So overall, it took 4.4 seconds. And the first thing I want to do is take a look at the details of this entry. And it gives me basically all of the data that I get if I were to intercept a web request. So I get the web request details, request headers, any cookies that came on the request. I can see what the user ID was. So if, for gets and posts, any data that's coming in, we'll be able to capture that. We have more of it turned on in IST than we do in perf, but in general, we can capture a lot of important data here. That's one thing that I think is nice. And then what I have down below is basically a detailed stack trace of what's happening and the amount of time that it's taking. So, for example, we have the inbox controller, inbox data method. Okay, I think this is IMS code. Yeah, so this is an IMS controller class. That right here.
Quick question.
Sure.
Can you filter out anything that is not IMS class or an IMS method? Like framework method?
I can. I can and I can't, right? So anything that I can do basically text filtering in this box. So I can filter for anything by, let's say, IMS, right? So I just hit Control F to do a find, and I want to type in IMS.
You know, IMS has to be somewhere in the class name or
class name, but it also could be the agent name too. So let me give you another example. Let's see that say that I wanted to know everything that was going on with coherence. So this is a way that I could filter all the GIF inputs pretty quickly. Without knowing what the classes and methods for IMS are, there's not a very effective way to filter.
Yeah, but what about the package API name?
The API. So
I know you have IMS over there,
right.
but you define a package. I think it uses the lowest level, right?
Mm-hmm.
But anyway, you see where I'm going, right? Is if you could have a generic API for IMS, if all the packages are like tom.ims, whatever.
Yeah, we would have to change the name of it for it to work, but that is a good idea. The one thing I would caution, though, is that it's sometimes good to understand how your code is interacting with the rest of the code. For example, the common services frameworks, I think it's good to understand where it's contributing time, as well as things like JDBC or Hibernate, right? So I understand it. I think what's a little bit more effective is if you're, at least from my perspective, if you're just trying to look for the hotspots, you're either using the graph to find kind of where the issues are. I guess it sort of depends on what you're looking to do. Was that Mandar who asked that question?
Yeah, I hear you. So it depends on what you're doing.
Yeah, no, if there's a specific class or method that you're looking for, that's pretty easy to search for.
Mm-hmm.
So we could look into doing that if you want. So let's go back to going through this a little bit. So here I see the inbox controller, inbox data. Of the 4.4 seconds, we spend 3.8 seconds of our time within this controller, beginning to end. Okay. You'll notice that there are a couple time columns here. There's a total, and there's an execution time. The total time is the time that it takes from the beginning to the end of the method. So if you set timers at the beginning and the end, this is the value that you would get. Okay. Execution time is basically you take the total time and then subtract all of the instrumented children. This is the time left over. So execution time typically tells you how much time you actually spend in the code in this method. Or, if it's large, sometimes there is some instrumentation missing.
No, I didn't go there.
But these two columns together can be pretty powerful to tell you what's going on. For example, the perform list method, right? So perform list method takes 860 milliseconds, and it has all these children, right? It makes some queries, it does some, calls this hash code a bunch of times, makes a few more queries. But what I know is that of the 860 60 milliseconds were spent in here, 660 milliseconds unaccounted for by its children. So in this case, the time that we're spending here is not being spent in querying the database. Because it's Hibernate, it's being spent generating objects for the most part. That's my assumption, and we would have to validate that in the code. But this is a good example where the perf engineering team would get to our analysis. Right? We would say, look, we know that there's an issue with this Hibernate mapping, or more than likely there is. So let's take a look at it together to see how it looks, if there's anything obvious that's wrong with it, and then we would work together with your team to kind of figure out what's actually driving this high time. Okay, that was a lot. I'm going to stop and see if there are any questions. No? Everybody good? Okay. I don't know if there's anything else useful that we want to go through here. But this is an example of that data iteration that I was mentioning before, so it's this kind of repeating pattern that we see. In this case, I believe there were, I don't remember the number. There were 225 items in the service request inbox. I just remember that from looking at this trace earlier. We make a call for